Good morning. Welcome to the lecture session on curve fitting 1. That is the first type of curve fitting. Today's lecture we are going to discuss how to fit a curve of the type straight line. That is y is equals to ax plus b or a plus bx. There are two types of straight lines which we can do it. The definition is curve fitting is a method of finding the relation connecting between an independent and a dependent variable for the given data. It is done by method of least squares. Fitting of straight line, y is equals to ax plus b or y is equals to a plus bx. The normal equations for the first type is given by sigma y is a sigma x plus nb and sigma xy is a sigma x squared plus b sigma y. Or for the second type, that is y is equals to a plus bx, we have sigma y is na plus b summation x, sigma xy is a summation x plus b summation x square. So we can use the normal equations, first one for the ax plus b and the second set for the a plus bx type. These are the normal equations. Next, problems. Fit a straight line y is equals to ax plus b for the following data, where x is 1, 3, 4, 6, 8, 9, 11, 14 and y values 1, 2, 4, 4, 5, 7, 8, 9. And we can observe there are totally 8 numbers they have given, that is data is 8. So n value should be 8. Now consider the equations for the normal equations for y is equals to ax plus b, which is given by sigma y is a summation x plus nb and sigma xy is a summation x squared plus b summation x. Let us call this as equation number 1. So we need to do the tabulation, that is x, y, x square and xy. So when we square that x square and x into y, that is first column into the second column, if we do, we get the data. We need to have the summation of x, summation of y, summation of x square and summation of x, y. So all this when we total, we get summation x is 56, summation y is 40, summation x square is 524 and summation xy is 364. So the normal equations are, for the first one, we have summation x into a, that is 56a, into n into b, that is 8b, is equals to 40, that is summation y, and sigma x square into a, that is 524a, plus sigma x into b, that is 56b, is equal to sigma of xy, that is 364. We have just rearranged and then written. On solving these equations, we get 0.64 for A, 0.55 for B. So that gives y is equal to 0.64x plus 0.55. This is the required straight line. Second problem of the next type, that is find the equation of the best fitting straight line y is equals to a plus bx for the following data, and hence estimate the value of the dependent variable corresponding the value 30 of the independent variable. Once we get the equation y is equals to a plus bx or ax plus b, what the value is required, that we can substitute in the x in the place of x and the corresponding value of y can be obtained. Now solution, given y is a plus bx is a straight line, the normal equations are sigma y is na plus b sigma x, sigma xy is a sigma x plus b sigma x square, and here we can observe n is equals to 5. This is equation number 1. As it is like x is required to compute a sum, y also let us compute the sum x square and xy. So we have calculated a sigma x, that is total of x if we take it is 75, total of y and x square and xy. Now we need to substitute in the formula, that is NA plus sigma x into b, sigma x is 75, n is 5, is equals to sigma y, that is 114, and sigma x into a, that is 75a, plus sigma x square into b, that is 1375b, is equal to sigma xy, that is 1885. So on solving these two equations, we can get a as 12.3, b as 0.7. So we get y is equal to 12.3 plus 0.7x. And in the question they have asked to find out the value, that is 30, corresponding to value of 30. So we can substitute in the place of 30, x as 30, and we can get the answer here. Next, put a straight line to the following data. Year is given as x, 1961, 71, 81, 91 and 201, 2001, and the production in tons is given by 8, 10, 12, 10 and then 16. Also find the expected production in the year 2006. Here, since the data is very large, year cannot be considered as x. We need to consider one of the midpoint. Here we can observe there are totally 5 points. So when we take this, 81 has to be used as the midpoint and rearrange them as x values. Let's see that solution. We have to find a production y in the year x is equals to 2006. As I said, x is very large, so x is x minus 1981. So capital X has to be computed by subtracting each of the year with 1981. Then the straight line will be a capital X plus b. So the new x value is computed by subtracting 1981 from all these years. There 1961 minus 81 gives minus 20, 71 minus 81 gives minus 10, 81 minus 81 gives 0, 91 minus 81 gives 10, 2001 minus 81 gives 20. And why? We are not going to change anything because the data is small. We can calculate what is x square and xy. Now we are not going to consider any x here. So after doing this, we can observe sigma x, since equally we are having negative and positive numbers, minus 20, minus 10, 0, 10, 20, everything gets cancelled, we get a 0. Sigma y, if we take it is 56. Sigma x square is 1000 exactly. Sigma xy is 160. That is after subtracting and adding, we will be getting this answer. That is xy. Now, we need to substitute in the equation. Sigma x plus a, sigma a plus sigma xa plus nb, where n is 5 here, sigma x is 0. So on substitution in the normal equations, we get the direct values of a and b, that is a value is 0.16 and b value is 11.2. So we are getting y as 0.16x plus 11.2. But x is not the real one what we require. X is to be replaced as x minus 1981. Okay, so we get y as 0.16 into x minus 1981 plus 11.2. This is the straight line. Now, since x is 2006, small x is 2006. When you are substituting 2006 in the place of the curve, we get 15.2 tons what is required. So, in the year 2006, we will be producing 15.2 tons. Thank you.